Hello everyone, welcome to another Google Cloud session. In this session, we will look into TPU speed data pipelines. So without any delay, let me start the lab. In this session, we are not going to discuss anything theoretical or any technical things. What we are going to do is like only we are going to follow the steps that is provided in this lab. So without any delay, let me open the lab in a new incognito window and do the setup first. At any point in time, you can pause the video and go through the uh, objectives and overviews for the additional reference. First, do the setup completely. Take to pause and continue. Okay. Now these are all the two objectives that we will learn in this session. So one is the TF data.exit and the second is to use the TF record format. So system and requirement, this is what I just did. So consider this is completed. Now set up the environment. So in Vertex AI dashboard, enable all recommended APIs. Okay, in the navigation menu, you can see the Vertex AI and dashboard and click on enable all recommended APIs. So this will enable all the required APIs. In task one, we are going to launch the Vertex AI notebooks, the Vertex AI Workbench user managed notebook. Now you can see in the Vertex AI Workbench, user managed notebooks, create. So let me give a name for this. I'll say lab workbench and TensorFlow 2.11. I just named it US Central 1, Central 1A. US Central 1, Central 1A. By default, it is created for the environment 2.11. TensorFlow Enterprise 2.1. I will leave the rest of it as default. You can see the machine types that has been used, disks and its sizes that has been used, networking is default, IAM and security, and system battery will be created. So this is going to take me about 2 to 3 minutes to create. So I will pause the video till then and get back. I will be able to see a open Jupyter notebook in this area which I highlighted. Okay. Now you can see there is a open Jupyter lab. Let me click on it. It will open in a new tab. Basically, it took me about 2 to 3 minutes to get this lab active state. So let's go back to the lab. Here you can see task one is successfully completed. Now let's close the course repository in the Jupyter Lab. Go on terminal, paste. This clone repository, you can download it in your local machine as well. Just to view the, if you have the TPUs, you can run it in your machine or you can clone it and then use it as needed. I'll go through the files that is required. Now task 2 is completed. So let's go to the task 3. So in this notebook, we are to navigate, we'll navigate to this specific location and TPU speed data pipelines. Open this file. So this is download is completed. So training data analyst in courses, machine learning, data 2, production ML, labs, and here we'll see TPU speed distribution pipelines. I open that line, I open this file. So to benefit at the time, I will open the solutions as well. Okay, TPU speed data parameters. Okay, now we will see two files, one with the solutions, one with the solution. Okay, we'll execute this. Okay, now let me select this and click on edit, clear all outputs. So all outputs are gone. So in the solutions, I have everything as needed for me, but in the lab, I will. So this is the same thing they are recommending, or they are asking to try to complete this notebook, but for the interest of time, I'm not doing it. Okay, let me import all the necessary libraries. This Jupyter Lab in this workbench. You can see the kernel is busy, so we need to wait until the kernel status will be good. I do. And also we need to see the TensorFlow Flow version 1.0. But in the lab, they already given us TensorFlow version 2.5, but we have advanced a bit. So this is again a full complete Python language code for data set to import, validate, training, those things. But I suggest you to download the file and go through the each line, um, how this matplotlib configuration will be done and where it will be get stored and all the data set. This code is not endless, it gets much better. Okay. And which is from creating, which is from local funds for testing, utility. These are all options. So it will take a lot of time to explain. So I will leave it to you uh, to pause the video or copy the file, and from your local machine, you can go through this. Yeah, at this point, I'm just shift and that means I will execute the file. So here, if you are to go, this is a good, you can see the strategy. There is a default strategy, a multi-workflow strategy, but here we are going to use the mirror strategy only. But here you can get other things if you need. And also you can see we are using the TPU strategy in this. So parameters, again, this is the batch size, running rate, decay rate, and images. Shift. So this is the parameters. And you can go through this link if needed. I have already seen this. Now you can see this link is something. This is the best practices for building an input pipeline. You can see data set, and there's a lot of information that will be used by you on regular basis, but I will leave it to you. As well. You can refer this link over here. Okay. Here we need to put our code to go to the solutions. Training data set and validation data set. Shift enter. Looks good. Let's look at the data. Again, I'm not going to explain all these codes, how the training is labeled and display digits and all. All you can do is you can go through the Python courses and get it from there. 3D layers and two text layers. Three convolutional layers and two text layers. Okay, this is 2D. These three convolutional layers. 12, 24, and 36. Let's see whether they will provide us a image for this. Okay, I think there will be an image for us to see. Okay, this is good. Again, we are making a model with the Kera sequential with the layers like three convolutional layers and two dense layers. Okay. I see summary over here. Print. Okay. Looks this is really good information. Now you can see there is an image. Analyst layers, fashion algorithm activation. This is first layer. This is actually first layer. This is second layer. This is third, and all which is the activation functions. Flatten dense layer, two dense layers. Let's train and validate. So training, we are going to see 10 epochs. So let's get started with that. 937 steps per epoch. So let's see the loss and accuracy. Let's see whether they print out the. This is taking more time than I expected. I would have. What I will do is I will pause the video. Now it is running in epoch 1. I'll wait for all the epochs to get completed and show you the loss and reverse. Let me show the first epoch loss and accuracy from the video. The loss is 0.12 seconds, 126, sorry. The loss is 0.12 and the accuracy is 0. Learning rate. Okay, I would not have seen. Okay, learning rate is set at okay, 0.7. Okay. For all the learning rate, it's going to be 0.0. Now you can see here the loss is 0.129 and accuracy is 0.96 and value loss is 0.04. Value loss accuracy is 0.98 and learning rate is 0.01. So learning rate is going to be fixed. So best we will see. So I will keep it run all the epochs and will come back later. In the meantime, we'll pause the video. It took me about 8 to 9 minutes to complete all the epochs. Now you can see the epoch 1, as I already mentioned, there was a loss of 0.12 and accuracy of 0.96. The accuracy gets started increasing and the loss becomes reducing. And you can see the loss got reduced in the epoch 5. The accuracy got increased in epoch 5 example. And the epoch 8, the loss become more and more less and the accuracy got more and more high. And also you can see the learning rate also getting reduced. At the final step, you can see the loss, accuracy, value loss, value accuracy. Yeah, yeah. So at any point, you can pause the video and just go a high level how the value accuracy, value loss, accuracy, and loss has been decreased or increased. So let's move on to the visualized predictions. So let's predict predictions from the local firms for brand predictions in red. 168 sample validation digits out of 10,000 with bad predictions in red and sorted first. Example 8, 2, 7, 5, a lot of still sample validation. Till here from row number 1, row number 2, row number 3 till here. This is a bad predictions. 9 images from data sets. Okay, let's see what it shows. Now let's configure classes Daisy, Tendalian, process on cloud and two labs. These are the classes and list of GPGs provided in this location. Now we have 9 images from the data set. That is the function or definition we have received. I can go to the solutions. Here, I completely paste it out. Okay. Let me run this code, but anyway, you can take a snapshot or you can go to the solutions file and then see the code like that. This is pattern, overflow storage, flowers public, okay. Partition denied. I think I don't have permission for this location. Partition denied error. Go back to this web page. Cloud storage. Oops. Flowers public. I don't see any bucket over here. I don't know why. I should be able to see the Google Cloud. It is already on the Google Business. Okay, so here I have not stored access to Google Cloud permissions. Does not have storage list access. What I will do is storage dot object dot list. Go to YAM. Scroll down. Storage admin access I maybe let me add that. What I'm doing is out of the lab. I think it is boring, but I'm looking for it. Cloud storage, seeing the cloud storage. Unfortunately, I couldn't fix the issue. There is some permission denied error. The lab is something not giving me. But when you see in other flower pictures in TF record, there is a collab from Google. Here also they are using the same GS pattern in the flowers public, and you can see some images. This is the same kind of code they have been using, and you can see this is the display set. So this is how we can see it. Here I don't see this error, so I can't proceed it. So let me go to the solutions tab. Here let's see what it displays. Here it is displaying some pattern images, and there is a read file, decoding by bits, labeling configuration. There is no output here as well. And also configuration again. The utilities read the labels. Now you can see again they are showing us the label, images and labels. This is in the solutions. Unfortunately, I don't have permission, or there is some issue with the GCS pattern. So this location is unable to access. I will try to re-record this and see, but overall, at any point you can pause the video and go through the steps over here. Pattern matches written as 16 while spending 230 minutes. Resize and crop images to common size. It is too low. You can pause the video and go through this text why this is too low. Decompressing the images. But I badly needed this. I can do is copy this. Open with copy. Go to any changes. Let me run through the code. So epoch system. So let me continue this code. So this is the visual representation of recognizing the valid digits. And you can see that recognizing from one here, first row, second row, third row till here. clusters. Our problem is this GCS pattern. Let's see if this gives an error and how permission denied there. Okay, this is a similar thing. This flowers pictures in TF record in a Google Colab. Google Colab. Here you can see I don't doesn't have permission to the storage or object of list in access information flow. When I see this, yeah, see I have an object viewer. Even if I change it to object admin, storage admin, storage object just including listing. So it includes listing, creating, and viewing. Um, Save. So I have both object admin and object viewer. So let me navigate to Flower Public. Still visit needed. Buckets. I don't see any buckets here. Refresh. Still I don't see. Go to the path. It's called Flowers Public. Go to the bucket. Now you can see there is an folder called Flowers Public, but I don't have access to it. Let me see whether this works. Source and destination is both same. Flowers. We'll talk in the location. Okay, so this is again out of the lab. So there is some issue with the lab permissions. So I'm just stopping this recording and I will report it and see how it. Thank you very much. Have a great day. Bye. What I will do is like from here, anyway, we have received an error here. This is the decode of GPEG, decode and labels, and auto tune has been used. Configuration again for the same flowers. Pattern, output, charts, target size, display utilities. Reading the images from the dataset one. It says and from reading the images from the dataset. And speed test too slow. Recompress. You can see the solutions as well. Writing TF records. Again, read from TF records. This is the list of Python code. You can go through this. Display set. Sunflowers looks good. But fast. Storing training is not a bottleneck anymore. Right? Okay. This concludes session. Unfortunately, due to the permission issue, I couldn't execute the rest of the test. But in this location, you can find a file and go through the steps in there. So that's let me close. That's end of this session. And have a great day.